So, picking up from our discussion on the introduction to sensory order and the essence of the problem, we arrive at a fundamental question. What actually makes one sensory quality distinct from another? The text suggests that the core difference isn't some hidden intrinsic property, but rather how these qualities interact, specifically, the effects they have on evoking other qualities or influencing behavior. Think about it. Red isn't just redness. It's redness because it reliably evokes warmth, certain emotions, and interacts differently with light than blue does. This immediately sets the stage for understanding sensory qualities not as isolated islands, but as nodes in a vast network of relationships. This leads us to a crucial point. The order of sensory qualities, much like the physical world, is fundamentally relational. We perceive this order so naturally because, well, our minds are essentially the map of these relations. It's not like there's a separate physical reality and a mental reality floating around. Our mind is the structure itself. Now, here's where it gets interesting compared to the physical world. While both are relational, the specific types of relationships differ. Physical events relate through space, time, causality, mass, charge, etc. Phenomenal qualities relate through similarity, difference, intensity, affective tone, and countless other dimensions we'll explore. The gap isn't just that one is purely relational, it's that the nature of the relations themselves is different between the two orders. Now, trying to pin down this sensory order explicitly is like trying to write down every single connection in a massive, dynamic social network. Why is it hard? First, many of these relations are unconscious background noise. We don't actively think about them. Second, we only become aware of them when we make a discrimination. Is this louder? Or does this taste sweet? The act of discriminating reveals the underlying relation. Third, the sheer number and complexity are probably beyond anything we could ever fully articulate. And finally, as we'll see later, this order isn't fixed, it can be variable. So, instead of aiming for an impossible complete description, our goal here is more modest: to identify some general characteristics of this relational system, focusing on the types of properties it possesses, even if we can't detail every single combination. One fascinating aspect is that despite being categorized into different modalities, sight, hearing, touch, taste, smell, the overall order of sensory qualities remains unitary. What does this mean? It means that any two qualities, regardless of their modality, can potentially seem similar or different along some dimension. Think about it. A bright yellow color might feel warm, like a hot tone. A deep bass note might feel heavy, like a thick texture. A sharp smell might feel intense, like a bright light. Experiments back this up. People can often distinguish subtle differences across modalities once they commit to it. The text mentions distinguishing a tone matching the perceived intensity of a lilac's perfume, a seemingly nonsensical task at first glance, but possible once you focus. This hints at deeper connections we usually overlook. Let's dig into how qualities vary within and between modalities. We know some qualities like colors or musical tones form continuous series, Helmholtz. Within these series, relations often hold consistently. For example, if tone A is higher than tone B, and tone C is higher than tone A, then tone C must be higher than tone B, simple enough. But does this apply everywhere? Nope. Look at color. Orange is more yellowish than red, and green is more bluish than orange. Does that mean green is more yellowish or bluish than red? Not really in the same straightforward way. Color variation isn't always linear along a single dimension like pitch height. However, we can still talk about dimensions of difference. We say blue is cool and red is warm. This suggests different modalities can vary along parallel dimensions or share the same type of difference. And notice how we borrow terms across modalities. A color can be strong, a sound can be sweet, a texture can be rough. These are intersensory attributes, often borrowed from one modality to describe another, showing those underlying links again. So we've established these rich intermodal connections. But here's the twist. In our highly developed conscious understanding of the sensory world, these cross-modal similarities often fade into the background. Our scientific thinking, heavily influenced by empiricism, tends to treat each sense modality as a separate domain. We marginalize these intersensory relations. When do we remember they exist? Usually when we're forced to describe something using borrowed terms. We instinctively reach for metaphors. A color is pastel, a sound is harsh, a smell is dry. These aren't just poetic flourishes. They point to genuine, shared dimensions of experience. And experiments confirm this. People tend to agree on which pairs or groups of qualities from different senses are analogous. There's a hidden shared grammar beneath the apparent diversity. This idea gets even more intriguing. Not only do individual sensory qualities relate to each other, but the relationships themselves possess qualities. It sounds abstract, but consider musical intervals. As the text notes, moving from a second interval to an octave, the perceived quality of the relationship changes. Gritty, pastel, rough, hoarse, sweet, hard, soft. Each step in the relationship has its own character. Furthermore, these qualities of relationships can be remarkably similar to the qualities of individual sensations. So, the structure of the sensory world isn't just a flat list of items, it's a multi-layered hierarchy of relations, each relation having its own set of characteristics. This relational complexity is key. Sometimes these intermodal connections become incredibly strong, leading to phenomena like synesthesia. Here, stimulation in one sense automatically and consistently triggers experiences in another, like seeing colors when hearing music. Interestingly, research suggests these links might be particularly potent in early development. This hints that our later, more rigid categorization, "this is definitely a red color," might be a more abstract, learned construct, whereas the initial experience is more fluid, blending modalities. Beyond these occasional strong links, most sensory qualities carry an affective charge. They feel good or bad, pleasant or unpleasant. This tight coupling between the sensory and affective orders is fundamental, and it manifests in expectations. We expect a red object to be warmish, or a delicious smelling food to taste good. Certain qualities tend to cluster together, creating a web of associations that shape our experience and surprise us when they break down. Okay, so far we've been talking about what we know through conscious experience. But does this sensory order live only inside our heads? The author argues strongly against this. Yes, our knowledge of this system comes from conscious experience, but that doesn't mean it's purely subjective. Experience teaches us something crucial. What seems similar or different to us often seems similar or different to others too. Think about basic shapes or colors. We assume everyone sees them similarly. And it seems clear that both humans, whether consciously aware or not, and even animals, base their classifications on what appears similar or different, mirroring the principles of our conscious experience. So the sensory order isn't just a private mental construct, it's a shared framework that operates even outside conscious awareness. Why is this sharedness important? Because it's the foundation for communication. How could we discuss the phenomenal world if others perceived it through a completely different lens? The fact that we can discuss it implies they perceive it with a similar, if not identical, order of qualities. Their minds classify stimuli in ways comparable to ours. So, while sensory system is subjective in the sense that it belongs to the perceiver, it's fundamentally interpersonal. It's not just my red or your blue, it's a shared system. And this extends beyond consciousness. We classify stimuli based on sensory qualities even unconsciously, and studies show animals do too. Higher animals, in fact, often classify stimuli according to patterns remarkably similar to ours. Famous examples include animals falling for the same optical illusions we do, like the chicks in Ray Vase's experiment. This strongly suggests the underlying principles of stimulus classification in animal brains are broadly similar to ours. Having explored the sensory order through conscious experience, we now need to broaden our perspective. Conscious experience is just one specific instance of a much larger phenomenon. From now on, let's use the term mental phenomena to refer to any events ordered by principles analogous to those we've seen in conscious experience. We'll put aside the specific question of what makes an event conscious for a bit longer. Chapter 6. The author argues psychology got stuck for a long time by focusing solely on the conscious aspect without having a clear definition of mental events independent of consciousness. The realm of mental events is broader than just conscious events. Talking about unconscious mental events isn't contradictory. However, while we agree with behaviorists about rejecting the old focus on consciousness, the author claims they went too far. In their attempt to purge consciousness, they also tried to ignore the problem of the qualitative order itself, the very structure we've been discussing. But this problem, as we'll see, is unavoidable, even if you're only trying to explain behavior. So how does behaviorism handle this issue? The classic behaviorists essentially denied or ignored the problem. Their stance was that psychology could get along perfectly fine without any information about subjective mental qualities. The job was simply to study the organism's responses to physical stimuli. But here's the rub. These schools inevitably ended up doing something inconsistent. They described the stimuli causing behavior not in purely physical terms, frequency X, wavelength Y, but using sensory attributes, a bright light, a loud noise. They accepted uncritically that different people treat stimuli as equal or similar, even if those stimuli are physically very different, simply because they appear the same way to the senses. They took for granted the very phenomenon, the existence of a shared, structured, phenomenal world, that gives rise to the mental order we're trying to understand. By focusing only on observable responses, they sidestepped the core explanatory challenge. The author argues behaviorism wasn't radical enough. Instead of starting from the objective physical world as physics does, they should have started by experimentally reconstructing how physical events produce responses. They should have grouped stimuli based purely on response patterns, essentially rebuilding the sensory classification system from scratch using only behavioral data. But they didn't do this. They accepted problematic facts, like physically different objects looking the same, or identical objects looking different under different conditions, without questioning why this happens. The Kohler anecdote about calling a female bird a stimulus perfectly illustrates this. Treating the bird as just a stimulus ignores the complex sensory qualities involved in recognition. By grouping all stimuli that produce similar sensory qualities together, behaviorists implicitly assume the very sensory order they claim to dismiss. They used the map they said didn't exist. Alright, so behaviorism denied the problem. But there's another camp, perhaps the opposite extreme, that raises a different kind of objection. They argue that even if we somehow manage to explain all the differences in the effects of various stimuli, we'd still be missing something crucial: the absolute or intrinsic nature of the sensations themselves. This view, tracing back to Locke's simple ideas and championed by thinkers like William James, posits that there's some essential quality inherent in a sensation that goes beyond all its observable effects. The author calls this a ghost problem. It's ill-defined, impossible to pin down precisely, and it's unclear what kind of answer would even count as solving it. Despite its vagueness, the author sees this idea of absolute, unknowable qualities as a major driver behind the historical search for a mysterious mental substance. How do we counter this argument about absolute qualities? The author offers a powerful line of reasoning. First, anything we can sensibly ask about sensory qualities must, in principle, be communicable through language. If I can't describe it to you, how can it be a meaningful problem for us? Second, any such description, any communication, will necessarily be in terms of relations to other sensory qualities. You can't define red without reference to other colors, brightness, saturation, etc. This leads directly to the crux. The question of whether your red is absolutely identical to my red is fundamentally meaningless and unanswerable. All we can meaningfully discuss is whether different people discriminate stimuli in the same way. Testing for colorblindness involves checking if someone distinguishes colors differently from us, not probing some inaccessible absolute redness. We communicate differences, not absolute identities. Think about a musician who can hear pitch differences far finer than most. Does that create a different kind of problem? No, it's still fundamentally about relative differences in pitch. The ghost problem dissolves when we focus on the relational nature of experience. This brings us to a practical thought experiment. How would we even begin to explain color vision to someone born blind? The author outlines a strategy. Start with concepts they already grasp: space, form, motion. Then, introduce the idea of perceiving qualities at a distance, like feeling heat or hearing sounds from afar. Next, explain that these new qualities aren't just one-dimensional like temperature. They vary along multiple dimensions: light, dark, bright, dreary, strong, soft, rough, sweet, pleasant, unpleasant. Point out how these qualities can combine to create harmony or dissonance, just like musical notes. Of course, we haven't systematically explored how far this teaching approach could go, partly because we lack the systematic vocabulary derived from understanding the sensory order's dimensions. But Helen Keller's work shows blind individuals can learn color names and use them convincingly. And considering synesthesia, describing scarlet as the sound of a trumpet, which Locke found absurd, now seems less so. It captures a potential cross-modal dimension. The text then critiques a famous analogy often used to illustrate the limits of objective science: the deaf scientist observing a violinist. The scenario describes the scientist meticulously observing the bow's movement, string vibrations, air pressure waves, and identifying repeating patterns, concluding they've achieved a complete understanding of the musical phenomenon. The author challenges this. First, this ignores the meaning of music to musicians. A full understanding wouldn't just involve physics. It would require knowing how musicians categorize frequencies into notes and intervals, how they perceive similarity, preference, and equivalence, a theory of meaning for the participants, not just objective waveforms. Second, the claim that the deaf scientist reaches an absolute truth inaccessible to the hearing is problematic. The author suggests this absolute likely refers to the richness and immediacy of the sensory experience, aspects that are indeed beyond description due to the limits of our conceptual systems. But this isn't a scientific problem. It's a limitation of our ability to capture the fullness of experience in words, not evidence of some unexplainable absolute quality. So, wrapping up this section, the core message is clear. There's no sensible problem about sensory qualities that doesn't ultimately boil down to differences and relations with other qualities. A quality's entire character is defined by how it differs from and relates to everything else. Trying to explain some absolute non-relational essence is futile, because such an essence, by definition, wouldn't show up in any difference in consequences, and thus wouldn't be relevant to scientific explanation. Recognizing this relativity, stemming from the idea that mind itself is an order of relations, removes the need for a special mental substance to account for these attributes. This shift opens the door to applying general principles to explain the entire sensory order. And importantly, since all mental qualities are relative, discussing them in terms of relations keeps us firmly within the mental domain. The next step, then, is figuring out how to bridge from this purely relational mental world to the physical world. That's the challenge we'll tackle next.